Okay, so we're looking at lesson 64 today. And this is just a very, very small introduction to the complex plane. Just a very small introduction to it. And then polar form of a complex number. And then we're going to look at sums and products of complex numbers. This is a very brief lesson, like regarding this information. We'll get into more specifics on later lessons. So they're all related to each other because they're all dealing with complex numbers. So there's a lot that can be done with complex numbers, like tons and tons and tons of stuff that you have no idea about, and I don't know about because I got out of that class. I didn't like it. I thought complex numbers was something else than what the class was about. I didn't like it. So when we graph complex numbers on a rectangular coordinate system, the x-axis becomes the real part of the number, and the y-axis becomes the imaginary part of the number. What is a complex number that you can think of? What's a complex number? Okay, I, but it's not just I. We have to have a real and an imaginary part. That's still just the imaginary part. 2 plus I, okay? So the real part, what is the real number part of this? So we go over 2. How far up are we going to go? Which is, what's the number in front of here? A 1. So that's where that is. Because this is our real part, and this is our imaginary. Instead of our x and y axis. So if it was a -3 plus 4i, where would you go? Somewhere over there? Does that make sense? Okay, so the book says this is confusing at first because I indicates up and down for the graphs of complex numbers, but over on the right side it indicates right and left for graphs of vectors. Those two mean the exact same point. This is a complex number. This is a vector. There is a difference in the notation, but it gives you the same point. Where am I going to go for -2i minus 4j? Left 2 and down 4. And where would I go for -2 minus 4i? Left 2 and down 4. These are called little carets. You probably have used them in English. You may not have used them in math. Do y'all remember that from a long time ago in Algebra 2? It's the same concept, just using I's and J's. Yeah, you did the R's and the U's for Algebra 2. Have y'all done the I's and J's this year? Oh. Okay, I've forgotten. But does that make sense? Okay. So it may be confusing, like, because you have I's in both of them, but the first number is the one that goes left and right. And then the second number, you go up and down. So that's just how you keep it straight. So when we graph vectors, we call the system of coordinates a rectangular coordinate system or a Cartesian coordinate system. That's what we typically graph on, a Cartesian coordinate plane. You just call it a coordinate plane, rectangular coordinate plane. Which you're frequently going to just call it as a coordinate plane. Whenever you're going to graph, you're graphing on a coordinate plane. Y'all don't usually say rectangular coordinate system or rectangular coordinate plane or a Cartesian coordinate system. Y'all don't use the Cartesian or the rectangular part. So that's when we're graphing vectors. Whenever you graph complex numbers, it's called a complex plane. They're very unique in their name, right? Complex numbers go on the complex plane. Or the Argand plane. And I'm assuming Argand is the person that created it. I really have no idea, and the book doesn't say. So I'm guessing that's who it is that created it, but I really don't know. But the complex plane is where you put complex numbers. It still looks very similar to the rectangular plane. The axes are just labeled differently. What's the only difference? It's not. It's just for information. Okay, so all of these represent the same point. So write them down, and we're going to go over them. I mean, you don't have to write them like in that lovely order, but I'll go over them after y'all write them down. Some of them we have done before. Some of them are new. Yes? That one in the middle is new. That one on the right is new. Yeah. You should have seen some of them at least. I hope you're kidding. They all represent the exact same point. What do you call the one right there? Is that rectangle? Polar. So this is what you learned to start off with. It's not even written up here. Because 2 squared root of 3 is 3.46. You're going to go over and then up. Okay? This is in complex form. You go over 2 squared root of 3, which is the same as 3.46, and then you're going to go up 2. You can also write it like this, down here. Going to the right because it's I, and then up because it's J, using your vectors. This one is in polar. We've used that one this year. 4 at 30 degrees, because it makes like a little 30-degree angle. And this is our 2 square roots of 3. This is our 2, and so that would be 4. So 4 at 30 degrees. That's where the 4 comes in. Does that make sense? This is another way to write it. We don't use this one hardly at all, but 4 at 30 degrees. It's the same as this one. It's just written in a different way.
I like it a little better.
Okay, so this one is what we're going to be looking at today. This is red. 4 CIS 30 degrees. Does that make sense? Okay. So this is CIS. This is the expanded way that you would write it out. CIS. CIS. Now, what is the cosine of 30 degrees? Square root of 3 over 2. What is the sine of 30 degrees? So what is 4 times square root of 3 over 2? 2 square roots of 3 plus what? Same as that one, right? It's a different way to write it. You just got to know them right now. Right now, just to know them. But these are all different ways to write the same point. A bunch of different ways to write the same point. Never knew that, huh? And remember how many different ways we can write this? 4 different ways? You could do the same thing here. 4 different ways. I mean, and you could also shorten it in 4 different ways. So there are like tons and tons of different ways to write the same point. Anyway, so now getting to what we're actually going to be using this for right now. We want to multiply these. Right now, you have no idea how to multiply these, do you? These really aren't too bad. So what you want to do first is make it into the 5 CIS 20 degrees. You want to make it into the short form. What would the second one be? 6 CIS 42. There's a common question that usually happens regarding the angles. Are they always going to give you the same angles for your cosine and sine? Yes. They're not going to make these two numbers different, because then you couldn't write it in this format. So they're always going to make those angles match up so you can write it in the short way. Okay? So now that you have it in this format, you're going to multiply the 5 and the 6 to get 30, and you are going to add the angles. That's your answer. Okay? So let's look at another one. No? How do we multiply them? They're already in the short format, right? So what do we do? 35 CIS 580. Do we like them to be 580 though? What do we want it to be? You want it to be 220 because it wants to be under 360. And you're done. That's all we're doing right now. Okay? Go into a minute on your homework. But now let's review for your test tomorrow.